To convert from this rectangular form to our polar form, we're going to start by just sketching. So we'll start with part A. So 1/3, if we draw this in the complex plane, is just a point here on the horizontal axis. That is, of course, 1/3, 0, or 1/3 plus 0i. Now to write this in my polar form, okay, r is the distance from my point to the origin, and that of course is 1/3. So I'm going to have 1/3, and then it's the CIS, and then of course the angle there, which I can see is an angle of 0. Okay, for B, if I draw this, okay, 2 plus 2i is 2 units in the real axis and 2 units in the imaginary axis. So that right there is what I'm looking at. In order to find that distance, I'm going to have to use the Pythagorean theorem. So I have a distance of 2 here and a distance of 2 here. And to find this distance, r, we have the Pythagorean theorem. R squared equals 2 squared plus 2 squared, which is 8. And so r is the square root of 8, or 2 root 2. So this number is 2 root 2, and then the CIS of the angle. And this angle I can see because these two lengths are congruent, that that angle is the pi over 4, or 45-degree angle. For part C, again, we'll go ahead and sketch our point, -3 in the horizontal and -3 in the vertical. Gives me a point there. And so that length right there, okay, that r, again, I'm going to use the Pythagorean theorem. So I've got a length here of 3 and 3 there. And so r squared is equal to 3 squared plus 3 squared, which is equal to 18. And so r is equal to 3 root 2. And so the number here in this polar form is 3 root 2, and then the CIS of the angle. And so we're looking for this angle here. It is a radian angle we're looking for, and because, again, those two lengths are equal, I know that this reference angle is the pi over 4, or 45 degrees. So this overall angle is 5 pi over 4.